Yo, what's up again, chem nerds? So here we go. I'm going to try to do this a little bit better and faster than the first video. Okay, so this is back to the August 2015 Chemistry Regents, the written response part, which I find most students have a little bit more trouble on than the multiple choice. So here we go, going right back to it. Number 54 says, a student drew the Lewis electron dot diagram below to represent sodium chloride. Okay, looks good, right? Not if you know what you're talking about. So it said, the question is, explain why this diagram is not an accurate representation for the bonding in sodium chloride. Okay, so to understand what's going on, of course, periodic table. Okay, so quick recap. This spot right here, that dark looking line right here, that border, it looks like a staircase. That separator separates the metals, which are on the left-hand side of the periodic table, except for hydrogen. Hydrogen is the only element that is to the left of that staircase border that is a non-metal. Everything else to the left of the staircase is a metal. So if you look, we have sodium, element number 11, which is all the way on the left. So sodium is a metal element. Then you have chlorine, which is element 17, which is all the way to the right of the border, which means it's a non-metal. So you have a metal bonded with a nonmetal. So let's check something else here. If we look up the electronegativity for sodium, let's see, sodium's electronegativity is 0.9. And we have chlorine's electronegativity is 3.2. So if we do 3.2 minus 0.9, we get 2.2, which is a large difference in electronegativity, or 2.3. And that is a large difference in electronegativity, which means that the sodium is going to lose electrons, actually one valence electron, to chlorine. So this is going to be an ionic bond. So let's do what the student should have done that they're saying they drew. So if we were going to draw the ionic bonding for sodium chloride, here we go. So sodium has one valence electron, which again, we can tell from the fact that sodium is in group number 1. And if you look at the electron configuration, you have that 1 at the bottom there. Okay, at the bottom right. And chlorine is a nonmetal with a much higher electronegativity, and chlorine has a electron configuration with 7 valence electrons. So 1, 2, 3, 4, 5, 6, 7. Okay, now since we know that sodium has a much lower electronegativity, meaning a strength for holding on to its valence electrons, than chlorine, which has a much higher electronegativity than sodium, that means that sodium will actually lose one valence electron to chlorine. And what happens is you get a sodium positive ion, which, by the way, a little silly that in the drawing we do not put the 8 valence electrons, but sodium actually does have 8 valence electrons after it bonds, because if you cover up that 1, if you remove that 1 valence electron and look at the electron shell underneath, that is 8. However, a little silly, but we do not draw the 8 valence electrons around the metal, but we do draw the total of 8 valence electrons that chlorine has after taking 1 from sodium. And also, since sodium lost an electron, it is a positive 1 ion, and chlorine is now a negative 1 chloride. We would change the end of the name to ide. So we have sodium chloride, positive ion, and a negative ion. So now if we go back to the question, look at what the student drew. They drew what looks like a covalent bond. So if we want to tell people why this diagram is not an accurate description or representation for the bonding in NaCl, there's a few ways we could describe this, but again, to save you my horrible handwriting, let's type out a few responses. So let's see, we could tell people that the diagram shows covalent bonding, but it should show ionic bonding. Let's see what else. So there's a few different answers. So we got 1 there. But what's another possible answer? How else could we describe this? We could say that the diagram shows valence electrons being shared, but they should have been transferred. By the way, if you see ionic bonding, ionic bonding is when electrons are transferred from one element to the next. That's why this represents an ionic bond. Again, we had the electronegativity of sodium was 0.9. Chlorine's electronegativity is 3.2. So the difference between them is quite large. So you get an ionic bond. There we go. So any sort of description, there's other ways to say it, but as long as you point out that the diagram does not show ionic bonding, and it should, then you will get the credit.